In this video, we're going to talk about the internal rate of return. Internal rate of return is another tool that we can use to assess the economic feasibility of a project, or we can also use this to compare between alternatives. It is actually one of the most widely used tools due to the fact that a lot of people recognize what it means. So a lot of people have a hard time understanding what present worth is or what future worth is, or even annual worth. It's confusing when you think, well, is that actual cash that I have, or is that what is that? Is that a value? Internal rate of return is a number that is used very often to describe how good or bad a project is. So it is also called investor's method, discounted cash flow method, or the profitability index. Now, this is it's also a rate, but it's not the same as the MAR. Here we're going to calculate this internally, and then we're going to compare it with the MAR. And if the IRR for the project is greater than the MAR, then the project is acceptable. What does this mean? What it means is, let's say that a company has a MAR, and let's remember that MAR is minimum attractive rate of return, has a MAR of 10%. That means that this company is assessing that it can invest, it has so many options or so many different options to invest money, that the one where it gets the worst or the lowest rate of return is 10%. Well, if your project gives a 12% rate of return, then it is better than the MAR, which means it is worth it. Now, if your project were to get, let's say, 7%, well, why would you invest in that knowing that you could take your money and invest it in something else that would yield 10%? That's what that means. It's easy to interpret. Okay, so how does this work? The internal rate of return is going to work based on some of the formulas that we have seen before, where we are going to have all the pieces of information and we are going to be solving for I. We have solved for I before, but now we're actually going to use that for decision making purposes. So it is really a break-even interest rate, and it's the IRR is the interest rate I prime, in which the revenue is equal to the expenses at the same point in time. In this case, you can do it at present, P given F, for a certain amount of periods. So you're going to take you're going to add all of your money inflow and all of your money outflow, make them equal to each other, and solve for I. Now, unfortunately, even though IRR is preferred, it's also a little more complicated to compute than present worth, future worth, or annual worth, because it requires doing things like interpolation. Now, we've talked about the fact that we won't be doing this by hand forever, and this is where Excel is going to be extremely useful. And there are two different ways to compute the internal rate of return. One is the IRR, and the other one is rate. IRR is a block functions, one of those where, let's say I have a cash flow and it has things happening in different periods, and you can highlight all of the periods and find the IRR. Rate is more when you have, the rate and you open parentheses, and per means the number of periods. Payment stands for like our annual or periodic payment of sorts, and present value is whatever our first cost was usually, and it'll give you a rate. Let's talk about calculating the rate of return. So first, we're going to convert various consequences of investment into a cash flow. Next, we're going to use one of the following equations to find the unknown value of the internal rate of return. Here are some of the equations, and a lot of these are the same. So if you see present worth of benefits minus present worth of cost equals 0, well, present worth of benefits over present worth of cost equal to 1 is pretty much the same thing. The net present worth is equal to 0. Again, same thing. This stands for, in case you should recognize AW, the E and U is equivalent uniform annual worth is equal to equivalent uniform annual benefit minus equivalent uniform annual cost. And we can use any of these in any combinations. Really, all you need is this one and that one, and the same one for future worth, and just you can manipulate the equation to help you. We can also set the present worth of the cost equal the present worth of the benefits. And step 3 is going to be, which I believe is in a different slide, but step 3 is compare that number that you got for your I prime with the MAR, and if it's greater than the MAR, you're going to choose, it's a good project. And if it's less than the MAR, then it's not so good. Here we have an example. Helen is buying a $12,375 car with a $3,000 down payment, followed by 36 payments of $325 each. The down payment is paid immediately, and the monthly payments are due at the end of the month. What nominal annual interest rate is Helen paying, and what effective rate? Okay, so how do we find this number? Well, let's draw our cash flow. So we have, let's see, 0, 1, 2, 3. We have 34 periods, which means that I'm just going to go like that. That looks like a resistor. And 36. So there is a first, a down payment. Well, first of all, she's receiving a benefit that is worth $12,375, but she's putting down $3,000, and she will be making annual payments, not annual, period payments of $325 per period, per monthly period. So first of all, let's find the nominal annual interest rate. This is the rate of return, internal rate of return. What is she paying? So we're going to set the present worth of the costs equal the present worth of the benefits. My only benefit is this one, and it is already in present worth. So then I can just leave it as it is. And actually, let me switch these two. We're going to make that B and that C, just because that's what we're used to more, a little bit more. B, C. 1, 2, 3, 7, 5. What about this one? Well, we can either subtract it right now and call it a benefit, or we can put it over here with the cost. So just for consistency's sake, I can write here 3,000 plus 325. And watch that, I'm keeping these positive because I put these in separate parts of the equation so that they could be positive. And then we have P given A, I, this is going to be my IRR. I'm actually going to write IRR. And it is going to be for 36 periods. And how do I find I now? So I'm going to solve this, kind of leave this part alone. So I end up with P given A, I36 is equal to 28.846. Okay, so now if I look this up in the tables, I'm going to find that I is equal to 1.25. If you, I just happen to have the 1.25 table with me, so I could find this exact number. If you don't have it, you might find that it is between 1% and 2%, and you would have to do interpolation. Okay, which I believe we're going to review interpolation in the next problem. So what is this? This is the nominal, this is the nominal rate per period, so per month. So to get the nominal annual interest rate, I'm going to multiply that times 12, and I'm going to get 15%. Now let's find the effective interest rate. So I'm going to do I sub A is equal to, let's remember our formula. It is 1 plus R over M to the power of M minus 1. Okay, so let's replace some values here. So 1 plus, what's R over M? Well, R is 15 and M is 12. So if I do 15 divided by 12, I'm going to get 1.25. So I'm just going to write it here, 0.0125. Sorry about the terrible handwriting here. To the power of, what is it, 12 minus 1. And what I get is, and I lost my place in my notes. 16.08%. So these are my two answers.